Can you hear me?
Yes.
Hi. How
Hi,
are you doing?
Sandeep.
How are you, Tahir?
Great.
Thanks.
I'll just get up. Hi, everyone. Good. So, yeah. So, how many of you have finished the exercises, the one that we discussed last time?
Yeah, actually, I've been trying to catch up with the previous modules. And even missed last evening's session. Yeah, let's see how much of it we can cover today.
Okay. Okay. Good. Good. Yeah. Anyone else? Deepak?
No, I didn't do it.
Okay.
Sorry.
Yes, I did. I sent the email.
Neil?
Yes,
Yeah, I did the exercises. I'm just
Okay.
trying to find where it is, but it is there. Should I post the code?
Yeah. Share your screen.
Share my screen. Okay, sure.
Wonderful.
There. Are you guys able to see my screen?
Yeah.
Yes. So this is the softmax one, and I think this is the. I did it a couple of days ago, so I'm still just trying to find. Okay, so this is the guess one, and this is the softmax one, which we had to do it.
Okay. Walk me through the guess one.
Walk you through the guess one. Okay. So what I try to do is to ensure that we can do it for the any nth power of whatever which we are trying to find. So
Interesting.
so you can do it for like square, you can do it for cube, you can do it for whatever, and it takes into the variable into consideration. I just gave a base assumption that the first two guesses which we are going to do is just 0 and 100, and the first middle is always going to be 50. And from that point onwards,
Why not have, let's say, left as 0 and right as n?
right as n. Yeah, that's also possible for sure. That definitely. Yeah, that also works. Let me see.
Okay.
Yeah, exactly. That makes it much more smaller.
So
I
you
just
calculated the 1/6 root of 64.
yeah, 1/6 root of 64. Exactly. That's
That
that's
comes
how
to
I'm
be
given.
true. Yeah,
So
it comes to true.
you can do it for any, like you can do it for square,
Yeah.
you can do it for cube. Everything, most of the things work. The only thing which is, let's say, the main point in this is like the only, let's say, formula which I changed from the ones which we discussed to make it to nth root is I just gave an nth root variable, and whatever the guess is, it gets exponented into the nth root to find
Perfect.
if the guess is right.
Perfect.
And I think the last thing what I did is also is since it can go, since it never reaches to a range where it exactly matches the guess, I put, let's say, a range on it, like, oh, if it's like 0.1 like the 10th decimal is closest to the guess, then we should stop then and there.
Yeah.
So
Yeah. Yeah.
that's what I did, just so that it just does not go forever.
Yeah. Yeah. Very, very awesome. Just to know for everyone, Neil started coding only in this class, right? Yes. And yes, yes, you are
Wow.
good to go for many, now you're good to go for many software engineering interviews, by the way. Okay. And yes, so this is good. I think this is perfect. There are these nooks and corners that you can fine tune it further. For example, where you're doing the round and not equal to n. Okay. What you can do is that's also a good strategy. But the problem is if the n is a decimal number,
Oh, okay.
right?
That's
Right. Right.
yeah. Then for sure it's good.
Yeah. So the way you do it is that you compare the absolute value. So define another function called almost equal. Okay. So it takes two
Okay.
values, A and B, and returns if they are almost equal. Just say almost equal. Okay. It returns true or false if things are almost equal. Okay. Define
Okay.
almost equal. It takes A
Okay.
comma B. If they are almost equal, it just returns true. Otherwise, it returns false.
So how do you put that into words? If
So
A,
yeah, you define a tolerance. Okay, say tolerance is equal to TOL equals. Okay, tolerance is equal to e to the power, say 1 e minus 5. No, let's just say 1 e minus 5. That's it.
oh,
Okay. That's a notation, by the way. You can
oh, okay,
the way you can write number, or you can just say tolerance is equal to 0.000001.
okay,
Okay. Now
okay.
what you do is you subtract a and b. Say diff equals a minus b. Okay. Now convert it into absolute value. So if diff is negative, make it minus diff. If diff is negative, make it positive. Yeah. Diff is less than 0, perfect. Make it diff equals to minus diff. Okay.
Okay.
And now you say if diff is less than equal to tolerance, return true.
Is it less than equal to or greater than equal to? Oh, this is a
No,
different. This is a different one, right? Yeah. Okay.
no.
Less than.
Yeah, less
Yeah.
than equal to return true. We are saying almost equal, right?
Oh, yeah. True. Okay. Return true. Yeah.
Else, return false. Yeah.
Else return. So,
Or you can just say return false because anyway
oh
there is
yeah.
a diff.
Yeah. Makes sense.
Perfect. Now,
Okay.
all right. Now you can call this function in your while loop.
Okay.
Okay. In that while condition, remove that
Uh-huh.
condition. Yeah. Here you can just replace it with the guess number should be nearby to that, right?
The guess number should be nearby. Yes, exactly.
Yeah.
Yeah.
Just say while not. Okay. Just say
Not.
not space almost equal.
Okay. Left.
No. Just call that function
Oh, sorry.
almost.
Almost equal. Yeah. Sorry. Forgot about that. Almost equal. Yeah. And A comma B, you would put N and V.
Guess
No, not
power, comma n.
guess power comma N.
Now,
Okay.
now test it out.
Okay. Let me just one not. Six, seven.
Okay.
Yeah.
Yes. Now you will see
Ah.
accuracy to go really well,
Okay. Okay.
right? So the square root of, yeah, yeah. Okay.
Right. So yeah, now it's much more accurate
Yeah,
compared to mine.
yeah, very good. Very good. This is a very good work. Super impressive. Okay. All right. All right. Now convert to probabilities. This is very good work, by the way. This is very good work. And you will find that number of values, the number of problems that you can solve with binary search is just amazing. Just amazing. Tahir, is it okay if I just turn on mute? There is a slight noise that is coming. Yeah, thank you. So whenever you have anything, just unmute and ask. Okay. Yeah. There is, I don't know why there is a, oh, maybe the fan is on your side, Tahir.
No, I think the fan is on my side. Probably that's why.
No, no, on Tahir's side, the noise was there continuous.
Oh, really? Okay. Okay.
Okay. Yeah. Convert to probabilities is, so I hope this almost equal function was clear to everybody. Yeah. Feel free to ask questions on this one. Neil, you can just zoom it a little bit.
Yeah, sure.
Everyone? So we basically wrote this function called almost equal because when we are comparing decimal numbers, you could never compare decimal numbers like as is like these two values are equal. And as a matter of fact, you will find that sometimes 2 will be called 1.00, 1.00000, 1.999999. Okay. Sometimes 2 will be called 2.00001. So there is no absolute values in. Okay. So is this function clear, everybody? Any doubts on this function? No doubts? Okay. All right. Good. Good. And is the square root, is the nth root clear to everybody? No. You want me to walk through this code?
Yeah, if you can do, Sandeep.
Okay, perfect. So what we are doing is we are going in the opposite direction. Okay, what we are doing is we are doing the inverse. So what we are doing is, let's say we want to find something's square root. Okay, what we do? We just guess a number between 0 and that value. Okay, and see if the square of that value is less than the target or greater than the target. Okay, and as a matter of fact, most of the time, most of the people actually use this technique. Okay, so I'll be very very honest. So long back in my childhood, I asked this worker, how do you divide two numbers? Okay, and this worker, so I was working in the farms, and I just asked this worker that how do you divide these two numbers? So what he did was he actually just did the guesswork, took out number in between, doubled it, and saw, oh, is it coming to like this or not? And so he kept on guessing it. So essentially, that's a very common technique that we use in normal life. Okay. So what we did, let's say we are talking about the square root. Okay. Pth root, instead of pth root, we'll just talk about the square root right now. So we basically took, let's say we want to find the square root of 64. Okay, so what we did, we took 0 and 64 and guessed a number in between the two number, right? And said, is the guess power um, equal or not? All right, and that's about it. And there, the guess power initially you can set it to 0, okay, and that also makes a lot of sense.
So
Okay.
Sandeep,
Yeah.
why we need to set it 0? Because in the next line, which we can see is guess is equal to right plus left divided by 2 also.
Guess. Yeah. So we are taking initial range 0 and n, right? Right and left. So we said, okay, 0 and n is there. Now we are guessing it in the midway. We are guessing between the two in the center of it. Okay. And after we guess, we do the square of it. Okay, we do the nth square of it. And then whatever value comes, we check, is this greater than n or not? Okay. Also, Neil, what you can do is here itself, inside the loop itself, you can check if it is almost equal, then break. Otherwise, if the guess value is greater than n, then do this. Otherwise, do that. Okay. Right?
Could you explain what do you mean exactly by that? So where should I place like the if or almost equal to achieve that?
Yeah. So you can say if, all right, I'll just code it up. That'll be
Okay.
easier for everybody.
I
Okay.
can send you the code if you
Yeah.
want to.
You just share with everybody.
Yeah, I'll just share.
Very proud of the fact that all of you were able to. I'm super proud actually. Okay. All right. I'll just create a new notebook. Okay. And June 7. Okay. Perfect. All right. So what are we trying to do? We are trying to compute the square root. Okay. Whatever is the number n, we want to find its square root. Okay. So what we do is we basically say, okay, the guess, we will guess a number between n and 0. So let's say we are trying to find the square root of, say, 5. Okay. So, right, the square root of 5 could be between 0 and 5. Correct. It could be actually 0 and 5 by 2 also. Okay. Well, let's be safe. So, right, the square root will be somewhere between 0 and 5. That's right, everyone?
Yes.
Yes, Sandeep.
Yes, Sandeep.
Okay. 0 and 5. So what we will do? We will make a guess. Okay, we'll say, okay, my guess is, all right, and initially the left is 0 and right is 5. So these are the two extremes. Between these two values, my guess will be there. So I'm saying left plus right divide by 2. Okay. Now we'll check if, okay. So now this guess will be there. Let's say the guess, right? We got the guess as 2.5. This will be initially 2.5, correct? Now we'll check the square of it. Okay. We'll check the square of it. The square of the guess. Okay. Square of guess is how much? Guess into guess. Right? And this comes out to be 6.25, right? Okay. Which is bigger than this one. So what do you do in such case? That means our guess is higher, right? So we chose something between 0, 2.5 and 5. Now the next guess will be somewhere between 0 and 2.5, correct? Because all the numbers, if we make a guess like 2.6, that will be higher, 2.7 will be higher. So our next guess has to be between 0 and 2.5. Correct? So what we do, we'll say, okay, left remains same. My right becomes, okay, right is equal to, right becomes 2.5, which is my guess current value. Okay. Now again, we do the same thing and we keep on doing that. So like we basically calculate the guess. How much will be the guess next time? The guess will be between 0 and 2.5, and this is going to be 1.2. What will be that? 1.25, and the square is going to be somewhere like 1.5. right? And therefore we realize that this value, okay, so this time this comes out to be smaller than what we are looking for, the square. Ideally it should be 5, but it is 1.5. That means our left becomes, right? So we keep on moving between that. So initially, right? Or let me make the life simpler. If we were, let's say, finding the square root of 4, okay, 4, and nah, it'll be the same thing after a while. Okay, so let me see. Let me break down this part. Okay, so initially, okay, so what we did, we said left is equal to 0 and 5. Then we said, okay, my guess is going to be this much. Okay, my guess is going to be this much. Okay, and okay, the guess is 6.25. So what do? We said, okay, since it is higher than what we are looking for, we will say our, so our range was 0 to 5, and 2.5 was midway, and all the values above 2.5 we are removing. So our right is becoming the guess. Okay. Now, right is guess, which means the again we'll just calculate the guess between the two values. Okay, between 0 and guess. Okay, so this time it is 1.25, so which is lesser, and therefore we have to basically go between I'll just also print left and right. I think this is way better. Okay, I hope I'm not confusing you guys.
No, Sandeep, I think I'm following.
Okay, okay. And so again, those who are left behind. So what we're trying to do is we are doing the guesswork. Okay, guesswork is pretty simple. Guesswork starts with we are trying to calculate the square root of 5. Okay, we said, okay, we'll choose a value between left and right. So initial value of left and right is left is 0 and 5, two extremes. So we pick a guess between left and right. Okay, we pick the half of this. Okay, and the half is 2.5. Our square of 2.5 is 6.25. That means our guess is too high. Guess is high, right? We have to choose something lesser than 2.5. Okay, so that's why what we did, we said, okay, we will choose something between 0 and 2.5 now. So right becomes guess. Okay, and then we go back again here. You see, oh, this is too less. We are, I mean, the square of 1.25 is 1.56, which is too less. That means this time we'll say left is equal to guess. Okay, and now we go back here again. So between 1.25 and 2.5, it's choosing, and the middle point of it is 1.875. Now, this is 3.516, which is lesser, right? That means we have to choose a value that is higher than what we are looking for. So we'll say this, and okay, there. So it says, okay, this is still lesser. That means we have to go higher. So left is equal to guess. And now this is higher. Now we'll say, okay, go down. And there we have it. Almost there. Okay. So again, right equal to guess. We have to try it. Now this is lower. So we say left equal to guess. We try again. Almost equal. Okay. Now, let's automate this entire process, the one that we are doing here. Okay. We will say, we'll define a function called define almost equal, the one that we did. Okay. Or let me just write simply. Okay. We are saying define is square root, okay, of a number n. Okay, we'll say left is equal to 0, right is equal to n, and we say while uh, okay, true, okay, And let's run through the infinite loop. This is an infinite loop, okay? We run through the infinite loop. We'll say midpoint is equal to left, or you can say guess. Guess is a better word. Guess is equal to midpoint of left and right, okay? And then, right? Then the value of guess, the square of guess is how much? Square of guess, okay? The square of guess is guess into guess. And then we say, okay, we find the difference of the square of guess from our what is it called that? Our value, the one that we are looking for, n. N is the number that we are, right? If this difference is less than 0, we'll just convert it into positive, meaning the absolute value. Okay. Okay. So far, everybody's okay. So we calculated the absolute difference. Okay. Of course, there is a function called absolute ABS that also you can use. If you see ABS of -10 is 10. Okay. So I'm just using the ABS function, which is completely okay, just to reduce the code and make it simple. I'm saying if diff is less than, okay. So if diff is less than tolerance, okay, let me just define something called tolerance. Okay, I'm just defining it outside, or we can just define it somewhere inside the function. Tolerance equals 0e 0e minus 5. You can check what does it symbol means. Okay, quickly you can always, as a thumb rule in Python, you should just keep trying and checking things before you go ahead with this. So this is wrong. Now this is correct. Okay, so we'll just say 1e. This essentially means 0.0005. Okay. Sorry, 001. Okay. So we are saying if the difference is less than 12, okay, that means we have reached, okay, we have reached, and we will return the square root, which is how much? The guess value. The guessed value is almost equal if the square of the guess is almost equal to the actual number, right? Otherwise, we are saying else if difference, else if the square of guess, okay, is higher than n, meaning they are not equal, but the square of the guess is higher, which means the guess we made is higher than what is expected, which means that the right value becomes the guess, right? Else left value becomes the guess, which means we have to go higher. That's it. Okay. So yes, everybody okay with this code?
And for the last part, where you're saying the right value does guess.
Hmm. These two conditions, right?
Right. So we had that, right? Now from there you're saying, okay, we are going to take this tolerance, and that all seems logical. Now on this maybe I missed it. Like, how is it that if it is greater, we are moving to the right value here? So the right value
Yeah.
is
So let's say, let's take a case, right? Let's say in case of 10, okay, we chose 0 and 10. In between the value, our guess was 5, okay? The square of 5 is 25, which is higher. That means our next guess, our actual square root of 10 is this side or this side? Will it be between 0 and 5, or will it be between 5 and 10?
0 and 5.
0 and 5. So that's what we did. We said, okay, the right side, we will now set it to 5. and left side remains as is. Earlier right side was 10. Now we are setting it to 5. Got it?
All right. So guess is the midpoint.
Yeah, guess is the midpoint. So basically, this is the most important thing to pay attention to. Okay, like if so, we want to do the square root of 10. Initially, we took 0. Left side is 0. Right side is 10. Okay. Now the midpoint is 5. Now this turns out to be the square of 5 turns out to be 25, which is higher than 10. So, and any number like 5.1, 6, 7, all of them will be higher. That means it does not make sense to search this side. So now we will say, okay, the next, the right value will be here. So we will make the guess somewhere here. So we'll say right is equal to 5 and left is 0. Now the next guess value will be 2.5. And then in case it turns out to be too small, say 2.5 square is 6.25, which is smaller than 10. That means all the guesses below 2.5 will be smaller. Therefore, we'll just ignore this and we'll focus only on 2.5 and 5. So left becomes 2.5. Got it?
So,
Yeah, Tahir?
Yes, got it.
Okay.
Sandeep, that is our general understanding, right? Like what should be the value of 2 or 3, I mean, the square root of 10 or 5 and whatever,
Yeah.
right? We know, we have some idea. But at what point where the code is actually deciding, like, this is the exact square root.
Yeah. This is where what we did was, we did the approximation. Okay. So what we did was, we found the difference between the guessed values square and our number. So this difference should be within the tolerance limit. Okay. So if this is almost equal, okay, we are saying to the fifth decimal digit, we are just checking if the difference is less than this small value, we are saying it's okay. All right.
Yeah.
And if we want to, let's say, go till 8th digit, we'll just say 8 here and then reduce it. So this is kind of exact. Okay. You can just check. You can just check the math, right? We can say import math, and we'll say SQRT and 10. Okay. So we are almost there. You can see 8, 7, 7, 6. Okay. We can also try say 9. Okay. So this is the value. If I just try checking this. Okay. And what is our situation? This is our method. Okay. So yeah. All right. Can I just change it to say 15? Oh, no. It doesn't work that way. Okay. I think this is good enough. Right.
8 or 9 is good enough.
Okay.
And then so this is the square root, right? Like, but if and the square root would be, I guess would be, you just have to change the 2 with whatever value.
Yes. So what Neil did was, Neil wrote this pth root function, and what he did was right, pth root, okay, and passed p here, and instead of checking the square, what he did was he did the power here, and this should be okay. So you can see that it is actually easier than, okay. Correct? So all the formula that I learned in childhood to compute the square root is useless. This is good.
Yeah.
Guesswork. And to your amazement, The entire neural network and the entire chat GPT and everything is similar guesswork. Okay. Similar guesswork. Okay. We'll talk about that soon. Okay. So everybody okay till here?
Sandeep, I designed the code, but let me share my screen.
Yes, please. Go. This is the most important topic, by the way. In the entire computer science, binary search is probably the most important thing. The most magical thing, the DBA does the magic, is create the index on the database table. Internally, that uses binary search, and that makes the entire database faster. Okay.
Is my screen visible, Sandeep?
Yes. In big
Okay.
data, when people say about the big data engineering, a lot of work is all about binary search at the end of it. Okay, perfect. And rather than taking the standard use case of finding an element in an array, I've taken the square root with a purpose because square root is easier than I found based on my experimentations with the class. I found that computing a square root is easier to understand binary search than the normal searching an element. I'm come back to searching an element. Yeah, wonderful. I'm very happy. Okay, so all right. So you are saying square root of n. If n is less than 2, okay, return ny. Let's
Uh,
say square root of 1.9 is 1.9.
Correct. So that's the challenge. Like initially, when I define it, this was okay when we have a number is a whole digit. Like actual, when we have a 16 is 4, then the 25
Yeah,
is 5.
yeah,
It's
yeah,
able
yeah,
to do
yeah,
it.
yeah,
But it's
yeah.
unable to succeed when we have it the number which is not the complete square
Because
root.
you,
So that's the
because
Correct.
challenge.
you are doing the binary division actually.
Yeah,
Left, yeah. That's what
yeah,
I can see here, right? Sandeep,
yeah,
you can
yeah,
correct
yeah,
me if
yeah.
I'm wrong.
It's exactly comparing the whole numbers. Yes.
Yes.
Yeah.
Yes, yes. So that's why I would want you to not think about like the standard binary search code. Binary search. This is a standard binary search code where you basically look up for an element. So when you're looking up for an element, then you use this technique that you've done. Okay. And
Okay.
though your logic is correct, but you have to think through from the beginning. First,
Mhm.
yeah, this is a correct how should I flow of a binary search, but the terminal condition, finding the middle value. Okay, so there you can see that the when you are saying guesswork, right? So you are saying left plus right divide by 2. There you are doing the integer division. Okay, that is good for when you are dealing with the integers. Here we are dealing with the decimal numbers. Okay.
True. True.
Okay. All
Exactly.
right.
Yeah. That's why identify there is some challenge in the code, but
Yeah.
now you have just clear it out well.
Yeah. Good, good. All right.
Stop sharing.
Okay.
Sandeep, I have
Vivek,
sent my code as well. Uh,
why don't
I
you
have a
walk us?
challenge in the. I have a. Okay, sure. I can walk us through. So the challenge which I'm facing is that every time, like I think it's editor problem because when I run, sometimes the output doesn't come. Sorry,
Yeah.
I'm just trying to
So
show.
if you see asterisk over your cell, that means there is an infinite loop going on. Go to the kernel and stop the kernel. Interrupt the kernel. So sometimes
Okay.
what happens is when you're writing these loops, if specifically while loops, you end up getting into this. Like while one mid equals to this, if absolute, this is perfect, okay, and else if mid into mid is less than this, start this,
Then start
and
I'm making
else
a split.
perfect. Okay, let me again. This is the only thing I also find always difficult, so I go very slow. I read it out very clearly. If the square of the mid value square of the mid value is less than n, the number that we are looking for, that means which means the mid number that we have guessed is too small, right? Too small.
Yeah.
Therefore, we have to change our start to the mid so that we go to the higher side. Perfect.
Higher one.
Yes. Otherwise, we do the end equals mid, which means we go
No,
to the
start to mid. Yeah,
yes.
start to
Now
mid.
this is perfect. What's wrong with this code? This is
So
perfect.
like if I do 9, so sometimes like if I run even the cell,
Yeah. So it's
so
running
I,
in infinite loop. Okay. It's running in
yeah.
an infinite loop. So you
So
say
if I
absolute
open a new
value.
notebook, if I
Yeah.
open a new notebook and then paste, sometimes it works. So
Yeah.
I'm
Yeah.
not
So what you have to do, kernel, go to kernel, go to kernel, go to kernel.
okay.
No, go
Okay,
there.
yeah.
Kernel interrupt. So it's
Okay.
running in an infinite loop. So you have to pay attention there. Why it's running in an infinite loop? When you're
Okay.
passing 9, so what's happening is start plus end. Okay, 0 and 9. Okay, divide by 2, 4.5.
4.5.
Yeah. Put some print statement to just check what's happening. Okay. Print is your friend and use it wisely and in debugging. Okay. There used to be stepwise debuggers, but here, I mean, in Python, people use them. Okay.
So if I like maybe stop and start kernel, then it works. But now again, if I change here to suppose 0.9, want to
Okay.
square root of this.
Okay.
Okay, now it came. So every
Yeah,
time I
yeah.
have to like
Wait,
open the new
It's going
editor
in
and then
infinite loop. It's an infinite loop running there.
yeah.
Yeah.
Okay.
You see the
Yes.
asterisk there? Yeah. That means there's an infinite loop going. And please stop. Do the kernel stop? Kernel interrupt? Cancel it? Kernel interrupt? Yeah. Yeah. So basically, it's an infinite loop. It's not a problem with the editor. It's an infinite
Okay.
loop that you're running. Okay. So whenever you face this thing, there's an asterisk. When process is running, instead of in 13, you see that number written? There, you'll see asterisk there. Okay. If the infinite
Okay.
loop is going on. Okay. You do the kernel interrupt and try debugging your code. Okay. So you
Okay.
can
So
see here that there is a trouble. Go up, go up. Okay. Yeah. So let's see what happened here. So in 0.9, okay.
yeah. So
Can you, yeah, you're saying that absolute value of mid into mid
so 0
minus.
plus 0.9 by 2. So it will be like 0.45 will be
Okay.
the mid.
Yes.
And this is the first mid. So mid into mid, I'm not sure how much would that be, minus
Yeah.
n.
Yeah, that's okay. So that comes to be 0.6 something. No, 0.116 something. Yeah. So you went
Yeah.
increase that value, it came to 6.5. If you see, you are almost there. If you see, the mid value is 0.8 something, right?
But it's okay. I'm printing out mid.
Can you print
And
mid
like it.
square also? Yeah.
Okay. Yeah.
Yeah. Yeah. Oh, what happened? Oh, that print has a space, extra space.
And this. So,
Yeah. Okay. Yeah. Stop. Interrupt it, kernel interrupt. You see that asterisk there in the 9?
yes. 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 Yeah.
Okay. Let's see. So what's happening? Come down. What's happening is, if we scroll down, let's just see what's happening. Yeah. So it is not going up. Okay. The mid value is consistently 0.899.
0.899.
And there
Yes.
is no, you know why it is happening? Okay, who can
Yes.
help me debug this?
Sandeep, I think while is one, right? He is not returning within the while.
I'm breaking
No, he's doing the
over here.
break.
Yeah,
I'm doing the
break.
break over.
Break will break the while loop.
Yes, that will break. What if it is not always falling in that?
Can you print start and end also?
Yes.
This is interesting. But yeah, ideally you should just, instead of breaking, just say return mid.
Yeah,
Okay, that is easier than this
deteriorating.
one.
Yeah.
Yeah. But I'm just wondering, is that the issue?
Somewhere when it is stuck in the else part, I think it is going into
Yeah.
just assuming.
So start was this 0.9, then yeah. Okay. Let's see. Let's debug this. Okay.
Yeah.
All
So
right. End is 0.9 and mid is 0.84. Okay.
over here also it looks
Now,
good.
very important part. So this is a very important. Okay, this is a very important thing, everyone. The strategy that we used is wrong. The 0.9, so 0.9's square root will be bigger than 0.9. Isn't it?
Would it
Can you
be
do
0.
square root of 0.9? In another cell, just say math dot square root 0.9. Very good, very good. We got the very, very, very good thing. So my strategy was wrong. Okay.
We have
So
to do
yeah, math dot square root. Yeah, math dot square root sqrt and say 0.9. Yes. See? So it's actually beyond
okay.
right. So our left and right, and we are guessing always within those range. The right is wrong. You see, we chose
Okay.
right as 0.9, but actual answer is 0.94. So the other thing is just trying to go beyond 0.9 and it's not able to go, right? If you see your code is trying to go beyond 0.9, it's stuck there,
Yes. Yes.
right?
After yeah, I think after this 8997, it's like
Yeah,
stuck
yeah,
at
it's just
this.
trying to get beyond 0.9, but it's stuck below 0.9 because our extreme limit is that. You see that logic?
Okay. Okay. Yes. Yes.
So now a question to all of you, how should we solve this problem? It's a real bug. Yes, exactly. Thank you, Subodh. I think that's what you should do, Vivek.
Okay. N is less than 1, so by default. So end will be
No, no, no. No, don't return, just set. Add and
sorry.
if n is less than 1, then set end to 1.
Okay.
That's what he's saying. Very good. Set end to 1. And equal to 1. Yeah. Now test it out. Not bad. Now it's working. Change the limit, the tolerance from 0.01 to 0.005. 0.00001. That's a 0.5 zeros, 6 zeros, and 1. Just say cancel or overwrite or something. Just say file save and overwrite.
Okay, we can do override. Yes.
I think you have
There's a
opened
one.
2 notebooks in parallel. That's why it's causing this trouble. Okay. Just say file save and that's it. Save and checkpoint. Overwrite. That's it. Okay. Now, yes, I think you got the answer right now. You
Okay,
can,
so
yeah,
for
you
any
can remove this print statement for now. Just remove this print statement because they are unnecessarily causing the trouble. Yeah. Now test. Run. Okay, so you are close to what library is giving. How much that math dot square root gave? 0.9?
same around 0.94868. Here is giving us same
Yeah.
0.94868.
Perfect. Perfect. All right, everyone. I think that solves it.
Okay.
Very good. Very good.
And similarly for generic power, I use the same. So probably I'll here also
Yeah.
have to make the
Yeah.
same
Yes.
condition. Okay.
Yes. Yes. And
Okay,
yeah,
sure.
the suggestion that who gave that suggestion? Instead of returning outside, you can return inside the loop itself. Yeah, here. Okay. That's it. And you can
Okay,
remove.
sure.
That's pretty much.
Okay, thank you.
Okay, perfect. Okay. All right. Anybody
Hey,
else?
Sandeep, one quick question about the n power, right? Finding out the square root of n. Uh, is there a way we can do it without using the power? Because if we can use power, we can just put 1 by n, right? Power of 1 by n and get it.
No, you can define your own power function. No? You can just multiply the same one.
Okay.
Right? Power function is simple to design, right? Problem is with respect to decimal powers. Okay.
Yeah.
As you said, right? In case you can use the power function, then what's the point of defining it? You can always say power 1.1 by 9. Yeah. So you can, in such case, if let's say interviewer tells you, right? Let's say you are interviewing somebody at Amazon, you must have, right? And somebody
Yes.
uses the power function. Would you say, ask them to, you'll be okay with it?
No. No.
Okay. All right. So I think in those cases you should, I mean, you can just define a power function. And power function is pretty simple, right? Everybody, can you
Yep.
define your own power function?
Hey Sandeep, I have one question. What is the disadvantage of we are using the power function? Like the
No, so question, see, Subodh's point is that the problem statement is to find the nth root, correct?
right.
And if I allow in interview, if I'm allowed to use the power function, then I would, instead of writing binary search, I'll just use the power function. So usually an interviewer will say they don't use the power function and write the pth square root. And
Not use
then,
inbuilt library, right?
huh?
Not use the inbuilt library. Predefined function we can't use.
Yeah, yeah. So usually as part of the interview, it'll be, told that don't use the power function.
Yeah, okay.
In that case, just write your own. Okay. All right. Yeah, that's right, Subodh. We could just do this one. 1 by 2, we could do the square root. All right. Perfect. Perfect. I hope this exercise was useful to all. No?
Yes, indeed.
Now, you might say that it is a worthless exercise, okay? But to your surprise, there have been many cases in my personal life, not personal life, my professional life, where I had to code binary search. Okay. One such case was, okay, here was the problem that we were calling so when I was building the recommendation engine for InMobi, and we were doing the app recommendations. So let's say you have watched a certain number of apps that based on your past history, I was giving the recommendation. One of the part of the job was that we have to scrape all the data of all the apps from App Store. So given, let's say you have 10,000 IDs, and we were basically getting the timeout from the app ID. So App Store had a weird limit. App Store had a weird limit in which they had some internal limit. If the data grows beyond certain size, they give an error. So to find out which of and there was one more catch. Okay, so let's talk about this particular problem. So one very key problem was that if a single ID is wrong, it would just say error. Okay, so we were calling App Store URL with app ID 1, app ID 2, app ID 3, app ID 4. And if any of these apps, if one of them app is having error, it would throw an error saying this one has there is an error in the app store. Okay. If more than one had the error, then there was no problem. Then it could tell that, okay, these are the app IDs which have the problem. If one had the problem, only one had the problem, then it would just say error and will not tell us like which one has the error. Okay. So we had a list of IDs. Only one was wrong. And we don't know which one. So what we did, we broke it into half and then sent it. And whichever worked, like first one worked, that means the second one has the problem. Then from the second one, we again broke it into half, and then we basically quickly reduced the search space into half and half, and very quickly zeroed it down that this particular ID is having a problem. So only one ID had a problem. That's where we were able to use the binary search. Okay. And to your surprise, there would be many scenarios where you can solve things in your life with the binary search. For example, your application is not able to handle load beyond a certain limit. How would you find that limit? Okay, so you will start doubling things. You do the binary search. First, you keep on doubling, and then if it starts failing, you basically start jumping back and forth. Okay, so similarly, there are many scenarios that you can handle using binary search. Okay, it's not binary research, it's binary search. Okay.
So Sandeep, in
And
your scenario for app ID, so was that all incremental or because app ID in generally iPhone's apps are like
no,
GUIDs or
yeah, they're good. They're like
GUIDs
strings. They are not incremental.
strings?
Yeah, they're
So
not incremental.
so how did you like segregate them into
No,
end and
we
start?
basically took the whole list, cut it into half list, half this side,
Okay,
half that
okay,
side.
okay,
Make the
okay,
call with the first one. If first one gave the error, then this one has the problem. We don't have to touch the second half. Okay, we just
okay.
make this one as into half. If the first one did not give the problem, we don't have to check the second one because second one has the problem.
Yes,
We just
yes.
use that technique. Okay.
Sandeep,
And
what I
Mr.
was sorry. You can go ahead. or I can just tell you one thing in between. What I was thinking was, see, it's when you're not able to find out which app ID it is because you have only one as an error, right? So couldn't you just create like a fake app ID? And if it's two errors, it shows you like which app IDs have error, and you know one is wrong.
Yeah.
So the
Yeah.
other one is like what you have.
Yeah, that's a clever strategy. And yes, that's a very clever strategy. But yeah, so the important part is that we had only one error, one particular scenario which we had to debug. Okay. And yeah, the exact scenario is very different. But yeah, I just try to summarize it in a short way. So we basically, the problem statement here was only one ID was wrong, and that was causing the problem. But I like your approach. Yeah. Okay. All right. All right. So you can actually just search for take a look at the binary search problems. Okay. One is LeetCode has good set of problems. This one also has good problems. Okay. You'll be surprised to see that there are so many interesting problems out there that is that can be solved with binary search. Okay. Right. So okay, I think let me just go back to the first problem that people use. Okay. There are so many, usually people will not ask you to code binary search. Nobody would code you to nobody will ask you to code binary search. The problem will be like this. Problem will be you have, bunch of numbers. They are increasing and then there is a decreasing. There's increasing and decreasing. Find the peak of these numbers. Okay. Or you have a bunch of numbers which are first decreasing and then increasing. Find the smallest value. How would you do that? Okay. All right. Before jumping there, do you guys have any questions? This is good stuff. I'm super happy, super stoked to see that you are moving really well with me. Okay. So now let's just write another one. Given n sorted numbers, okay, given, or let me say, given array of sorted numbers, check if a number exists in them. Okay, so you have to define a function, search. It takes array and n and returns true or false. Okay, if the number exists. So we have to check if n exists in this. Okay, and the array contains the numbers in a sorted way. For example, I'll just put pass. Okay, pass means do nothing. Okay, say this is your array, and when I call this search method on this array, I'll say 1, it should return true. If I say search array 0, it should return false. Okay. If I say search array 2.5, it should return false. Okay. Now that is the problem statement. The numbers are sorted. They are not decimal, but they could be decimal, they could be integers, they could be normal Yeah, these are the numbers. How would you write the logic? Everyone? So first form of logic, we can write like a simple sequential logic, right? We can just check, right? For I in array, if n equals I, return true, else. All right. And in the end, if it is not found, it'll say return false. When the loop is over, we return false. Is this good enough? Will this work? Let's see. Okay. Are you done? Everyone? Now, so in this method, do you think that you are doing a good job? Is it fast enough? What's the complexity of this one, by the way? How?
Open.
Order of n.
N.
Order of
Order of
n.
N.
This is order of n, meaning if n becomes 10, the time taken to it, if n changes from, so if n doubles, then time also doubles, right? If n becomes 5 times, then time also becomes 5 times, correct? That's linear, or you can say order of n. Okay, now any improvement would you recommend here?
Binary search.
Yes.
Binary search, because we are not utilizing this information that these numbers are already sorted. Okay, these numbers are not sorted. I mean, we are behaving as if the numbers are not sorted. We are just looping over it and return. We are not utilizing this information that these numbers are sorted. Can we utilize this information and do that? Okay, so how would you solve this?
Like find the mid and then comparison in the two brackets, left or right.
Okay, let's see. So we are saying that our left is 0 and right is equal to length of array minus 1, correct? Now we are saying, I'll just go with my style. I usually like this style. Okay. Now we are saying, okay, the mid is equal to, we are picking the mid index. So we are saying my number exists between 0th index and the last index. So I'm saying left plus right divided by 2. This is the integer division. Okay, this is the integer division. So if
Why that -1 then?
huh?
Why you
Why
call that
-1?
minus?
Because I'm saying that I'm going to basically this is the location of the last element. This is the location of the last element.
Yes, so there could be say 20 numbers, right? 20
So yeah,
letters.
so the last element's index will be 19.
What's that?
Got it?
0.
So if let's say
It starts.
here, yeah, yes, time.
Yeah, so it starts from 0. So right, I mean the first entry you are considering as 0. So that.
Yes.
Okay, correct.
Yeah. Okay. So we are saying left plus right divided by 2, that's my midpoint. Okay, mid index. And then we are saying if we are checking that at the middle point, is the value bigger or lesser? Okay, so we are checking if at array mid, okay, at this midpoint, is the value equal to the number that we are looking for? If that is the case, return true. All right. And if that's not the case, that means that we are like the number at midpoint could be bigger or smaller. So we are saying else if the array, I mean the element at this place is, let's say, greater than n. So if the number, so let's say we are looking for 2.5, or let's say we are looking for say 5 in this, we are here, that means we can only search for the number this side, correct? Number this side. Now what we do, we'll say the left side is equal to the mid plus 1, because mid we have already checked, so we don't need to check mid. We are saying left is equal to mid plus 1. Okay, else right is equal to mid minus 1. Okay, so all right. And yeah, here there is another trouble. Okay, there is another trouble. How would it stop? When do we stop? Okay, when do we stop? Let's say we are looking for 5 and that is not found. Okay, so first of all, we went to the middle of it. Okay, we checked. Okay, let's see. So this was our number. Okay, we were here. So we jumped to the middle point. We went to the middle and checked, is this value equal to 5? It says no. Is it value greater than 5? It says no. This value is less than 5. So we say, okay, that means we have to only search on this side. Okay, so we say, okay, this is my left now, and this is my right. Okay, now when we say mid, the mid is going to be now this. Okay, because we are saying left plus right divide by 2, that means it goes to this. Okay, midpoints here, and that number is again smaller. So what we do is we jump on to this. Only one element is left here. Okay, the only one element is left, and the midpoint of the left plus right is going to be the same number. And then since this number is big, I mean smaller, I mean this number has got only single value, and what will happen is that my left will go one right to the right and so on. So we can simply say that as long as left is less than or equal to right, let this loop continue. Okay, so let's take a look. Is it working? Is my function working? Let's see. Search in this list of values. Okay. All right. Did it return anything? Nothing, because we did not return anything. Okay, that's about it. So it says 5 is not found. Okay, 1 is again not found. I don't know why. Let's just take a look. So
If the condition is elif, no, that is array of mid should be less than n, right?
okay, array of mid. Oh yeah, yeah. You are right. Because if the element at this is smaller than n, then go towards the right, otherwise go towards the left. Okay. I think this makes sense. All right. Now, let's take a look at, does it work with single element? Okay. Does it work with single element? Okay. So in the single element, left and right both are 0, correct? So mid is going to be 0. Okay. Mid is going to be 0. And here again, I think you can just print left and right. Left. Okay. Left is left. Right. Okay. All right, I have to put F. So both are okay, like this. Now I also want to print. I think this is a good way to debug it. Okay. So let's say I'm looking for 1, 2, and I'm looking for 1. Okay. So the midpoint here, instead of taking exact midpoint, we are just taking the rounded off value. Okay. So if left is 0, right is 1, the mid value is 0. So array of 0 is 1 here, and it just checks and returns quickly. If I say 1.5, what will happen? Let's take a look. So what happened first time? 0. So left was 0, right was 1, mid was 0. Array of 1, array of mid value is 1. Okay. And here the okay. Again, so what happened, since this was 1 and we are looking for 1, it is going to go, to the right, which means it will increase the left hand value to mid plus 1, okay, which is 1. So left and right both are 1, and it goes here. And what happens afterwards, okay, what happens afterwards is, okay, let's say after change, also let's print, okay. And okay, let's just, put F there. Okay, left is 0, right is 1, mid is 0. And then you can see here what it did was after the change, left became 1 and right remained 1. And then here, when it checked, it is 2, which means we are looking for less value, and it is actually 2. That means it has to go left. So now it reduced the right side by 1. Left side is right. So the left was 1, right is 0. That means this condition is no longer valid, and it exits. Is everybody okay with what's happening? No? Yes, everyone? Why is there so much
Yes,
silence?
yes. No, yes. I mean, this is, yep.
Yes, Sandeep.
Okay. Everybody is comfortable with this?
Yes. Yes.
Yes.
Okay. Okay. As a good assignment, you must do it at your own time. Okay. Do not try to just memorize it. Go back and code it. Okay. Trust me, you will fail many number of times. Okay. So there is a saying, very popular story in a book called Programming Pearls. If you have heard that book name, has anybody heard about this book named Programming Pearls? Yeah, this one. Okay. This is a very great book if you are interested in computer, specifically algorithms. It's one of the very, very great books. It's a fun book to read. Okay. Programming Pearls by John Bentley.
This is the algorithm book or Perl
Yes,
script? So then why Perls? I thought Perl
Is it a
script.
Perl programming? Is that a Perl programming or just
Okay,
a
okay.
normal name with Perls?
the name. That Perl programming's spelling is Perl.
Oh,
Okay.
yes. Yeah. Okay.
This is in Hindi, they call it moti, that's what is Perl.
Yep.
Yeah. Okay. All right. All right. So I would request everybody to. So in this book, there is a very good story. So what one of the professors did was to the top engineers and scientists, he gave 1 hour to write binary search. Okay, the code that we just wrote. Okay, so and to his surprise, only one out of say 100 great engineers were able to write correct code. Okay, it's a real story. Okay, and the main reason is because there is these indices and the terminal condition when to stop the loop. That's where the problem arises. Okay, it would always get into infinite loop, or you will miss out on something. Okay, so don't take it lightly. My request is to code up everything. Okay, all right, all right. Okay, I'm just looking at the code by Prashant. Prashant, do you want to share your screen and I can walk everybody through the code? The code looks right to me.
Yeah, I'll
Go.
share the screen.
Yeah, I'm just wondering. The only thing I'm seeing as a problem is that it would have the overflow because the right endpoint is one bigger than the actual value. Yeah, it'll have the overflow.
Okay, so when
Now it's correct. Now you have corrected it. The second line is okay now. I was looking at the comments.
okay,
Oh. And that line that you are saying mid equals to left plus right divided by 2,
Hmm.
you can just deduplicate it. Just put it only once in the end. Okay. Yeah. Keep it only on the end. Yeah. No. Let that be there. Let that be there because that'll be needed to you. Or why don't you compute the mid just in as soon as you enter the while loop. Just enter the while loop and then do that. Because you are repeating that code. That code is right, just that yes.
Okay.
Now I don't think you will need the first mid calculation.
Yeah.
Yeah.
Okay.
It should work now.
Yeah, that's okay.
Yeah. Okay. Perfect. Very good. Very good. Any questions on this? It's very important for everyone to start working on this. This actually helps you. Okay. Now my question to all is, what is the complexity of binary search?
Log n.
Log n by 2.
Log n, where n is 2, right? Base log 2. Okay.
I love
Yeah.
this too.
Base log 2.
And base log 2.
Can anybody prove it? Go ahead. Go ahead.
Every time we are dividing it in the list into like half, right? So,
Yes.
so only it will not go beyond n. Like it will not be order of n. It will be n by 2 always. So that
N
is
by
why
2 every time it is
every
half being half, right?
But in some cases, I think when non-existing element in an array of size 2, it is going 2 times. In some cases, it is going to n.
Yeah, in some cases. That's the
Yeah.
worst case.
Okay.
Okay. But that we can ignore because we are talking about the order.
Okay.
Okay. All right. Go ahead. Go ahead. Anybody wants to explain better? Okay. To like 6-year-old a kid, can you explain?
Yeah, I can try.
Okay, go ahead.
So, like in every iteration, we are dividing the array size, like the n size by 2. So
Yes.
after k iterations, it will be n by 2 to the power k.
Yes.
And we'll have to do this until like we just have one element left.
Yes.
So n by 2 to the power k should be 1. So
Yeah.
that gives,
Yes.
I think that gives k equal to log n
Basically,
base 2.
log. Yeah, there's a definition of log. Yeah, perfect, 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 perfect. All right. So yeah, I will probably explain the same way that initially our entire range is, let's say, 0 to n, step number 1. In the step number 2, the length will become n by 2, right? The range. Then n by 4 and n by 8. Okay, it'll keep on going. So after a while, basically only one element will be left. So you can say that this length is equal to 2 to the power steps. Okay, 2 to the power steps is equal to n. You might also say it is 2 to the power steps plus 1. Okay, right? Now, if you see how many steps are there then? The steps are equal to log of n. That's the definition of log, by the way, right? That's how we define the powers of the base is called the log. Okay, right? If you remember the definition of log, right? A to the power b equals to c. So b is equal to the log of c with the base a. That's the definition. Log is nothing but the powers. Okay, the number of zeros, if we are talking about the decimal, number of zeros in a number is called the log of it. Okay, log of 10 is 1, log of 100 is 2, and so on. Okay, if you can express, let's say, some number into the powers of its base, okay, let's say 5. What is the power of x? 10 to the power x, that leads to 5. Okay, okay, so this x is called the log of 5. Okay, so that's the way we represent the log. And yes, log is a little notorious when it comes to the common sense, but in simple words, it's essentially that. So the complexity of binary search is log base 2 of the n, right? As we said earlier, log, no matter what base is it is basically can be converted into, let's say, log 2 base can be converted into log 10 base easily. Okay, you can say log of 10 of 2, right? By multiplying a number, correct? Therefore, it is when we are reporting the log, we just report. When we are reporting order or complexity, we just report log. We don't report log 2, log 10. Okay, so the complexity of binary search is log of n. What is n? N is the total size or range of the range that you need to search. Okay, in case of in case of let's say square root problem, what is n? Okay, okay, so if our precision is 0.00001, then these many numbers we need to try. So log of this value, right? Log of this value. Okay. Now notice that we can always represent it like log of n minus log of this number, which is essentially constant. So we always report it like log of n. Whatever number you are using, the log of that number. Okay, log of 10, basically the computation of square root with binary search becomes extremely fast. Okay, is everybody okay with this?
Yep.
All right.
I mean, here we have two assumptions, right? That array is sorted first of all, and there is no duplicates, right?
Correct.
So if the array is not sorted, then the complexity can vary.
Array, yeah, correct. If the array is not sorted, then you can't use the search method.
Yeah, okay. So we need to sort it, right? And what about duplicates? Let's say if you have more than one value.
Yes. You tell me. Do you think this code will run if this is duplicate?
I mean, yeah, I mean, if it is a first occurrence or the last occurrence, then it can vary, because if it is a last occurrence, then the program can be confused, right? Which one to pick?
Yeah. So that's why when somebody says search, right, they will tell you, okay, do you need to report? That's another very interesting problem. Okay. Now here is a question to you, that you have a list of zeros and ones. Okay. You have list of zeros and ones. Okay. And find the let me see. Okay, you have zeros and ones. Find the count of ones or count of zeros. Okay, and right, the array is sorted. Okay. So like, for example, right, when you say count zeros and you have 0, 0, 0, 0, 0, and then you have 1, 1, 1, 1, 1. Okay. And so the answer is here, count of zeros is 5. Okay. This should give 5. How would you solve this question?
I mean, one of the ways, I mean, just start from the index 0 till we encounter the first one.
Yes.
And the index will be that the value of the index will be the count of the zeros.
Okay. Okay. Help me code it. So define count zeros, right? And
Yep.
this is my array. You are saying starting from for I in range length of array, right? If array I not equal to 1,
and continue.
Sorry, continue. If
Yeah.
this is
Or the
1,
yeah.
replace. Okay.
Yeah.
And there is one problem. Okay. And we'll just say count equal to 0. Count equal to 0. And we'll just keep on increasing count otherwise. Okay.
Yes. Yeah.
And we just return count.
Yeah.
Okay. So let's see. All right. Let's see. 0, 0. Let me just copy this. All right. Yeah. So 5. What's the complexity of this one?
O of n.
Yeah.
Order of n. Right? Because it is going, it's a single loop going from left. Yeah. Order of n. Right? So that's the complexity.
Yeah.
Okay. Now, would you recommend something better?
The another way could be like you can use a binary search, and every time you identify the mid element and check whether the left or right value about the 0 and 1s. If the right value of 1, then you again check by dividing by 2 mid element, check for the element right, left and right. If it is 0, then you can say that number of count is 0. That number.
Correct.
Yeah.
Correct. Correct. Okay.
Or the binary search will give the first occurrence of 1. So before that index will be number of zeros. Is that possible?
Yes. So that's a good way to say. So yes. So when you are designing binary search, you can do that. Okay.
If you're allowed sum, then you take the left, take the sum, then tell the difference. That gives you the number of zeros.
Yeah.
I mean, without getting into binary search, if we allow sum, but in most of the cases we are told that okay, inbuilt functions are not allowed.
You are saying sum, right?
Yeah. So just take the sum
So
of
we
all.
can say sum. We in here. Let's take a look. I think I understood what you're saying. You are saying, okay, right? So you are saying return sum of array from length of array minus this, right?
Right. So it'll give the count of zeros.
What's the complexity of this one?
Yeah, it's again counting count 0. That we are trying to count that count function may not be allowed here.
Yeah. So see, length maybe order of 1, but sum is an order of n operation. It just goes and adds all the numbers for you. Okay. So this is order of n. Okay. If you see this problem statement in an interview, all right. So first attempt could be this, but specifically in case of Googles and Facebooks, if this is the question that you see, that means it is supposed to be a binary search.
Sandeep, why that is order of n, the first one, not this?
This one?
This one, huh? Anyways, it will break at first one, right? It will not reach the nth.
Yeah.
Anyway.
So it'll be order of n by 2, right?
Yeah,
and we always say that is order of n. order of n by 3, n by 5, 3n, 4n, everything is order of n.
Okay.
Okay. N minus 5, n minus 4, n plus 10, everything is order of n. Okay. Okay. Yes, Gaurav.
Yes, Sandeep, I have one question. In database search, like we have the duplicate row. Like ID is unique, but data is duplicate, right? We
Yes.
implemented the BST in the based on the indexing. Then
Yes.
how to find out like the data is duplicate by aggregate function we are using the find out the duplicate name or duplicate anything based on the column. Then how to BST is implement in the large data set?
Binary search or BST. There are two things. One is binary search and other is binary search tree. Both are different.
Okay, but yeah, like my question is how to search in the duplicate entry in the database internally, like when we use the aggregate method,
Mm-hmm.
how
No,
to
I mean,
search.
if you're just duplicate as in you can just do a group by and do the count, right?
Internally, how to work grouping method, like the
Grouping is sorting. So see the way if I have to do, let's say you have one of the very important problems is that you have uh, you have let's say you have let's say big text, okay, or let's say you have a set of numbers, okay, in an array, okay. Find duplicates, okay, right? How would you find duplicates? Okay, so the one that works well is the sorting, right? Sort the data, and find the find the neighboring duplicates, because the duplicates will go together, right? When the
yeah,
data is sorted, so you can just do that. But if you have to implement it, then I think what you usually do is you basically sort the data, create a binary search, a search tree. Okay, like here, I can probably take it up some other time because I think everybody will
yeah,
zone out when I
yes,
talk about binary
yes,
search tree. Okay,
okay,
and but the thumb rule is very simple. In binary search tree, the element which is less than or equal to, you put them in the left. Okay. All right. So I think we will discuss it some other time, probably. This is a
yes,
good question, hard
yes.
one. It's not an easy one.
Because we are aggregated method, but we don't know how to internal work that. That's why I
Yeah.
asked the
Yeah. Yeah.
data.
Yeah. So entire of the database is all about the binary search tree. Okay. There is a BST, there is a B plus trees, there are right? Though there are quite a few variants of this. Okay. We'll talk about that soon.
Yes, yes, sure, sure.
All right. Okay. I was talking about this very interesting problem. So how would you implement it, right? You will basically go to, let's say, middle point, check, is it the end? Okay. Or if this value is 1, okay. If this value is 0, go to the right. Okay. If this value is 1, go to the left until you reach a point where your values just next to it is 1. Okay. You can implement it many ways, but I would expect everyone to implement it in their own way. Okay. I mean, binary search takes a lot of time of practice. You will have to solve at least 10 different problems in order to get the feel of it. Okay. And you would make lots of mistake. Okay. And at least 10 different problems you have to solve. One of them is this. Okay. The second problem is, let's say, count once, where the data is sorted and the values could be like this. Okay, how would you count ones? Okay. So repeat the same process as previous twice and do that. Don't solve it like this, okay? One of the mistakes that people do is that they say, okay, I will find this using binary search, and once I found one, and then I'll start counting normally. Then again, you end up with order of n problem. Got it? So, sorry, here count once, okay? Okay. Problem statement is count once in a data that is sorted. Okay. In an array of numbers, in a sorted array of numbers. Count once, how many ones are there in a sorted array of numbers. Okay. So first find this corner, then find this corner, the right side, and then find the distance between the two. Okay? That you can find, right? Because you know the indices. Okay? Would you try these questions? This is question number, okay, right? This is question number 2 and question number 3. And question number 1, I would want everybody to code. Okay, this one. All right, I would want everybody to code this one. Okay. All right. So that's about. Everyone? Any doubts on this? The binary search one?
No.
Okay. Yeah, there were two more problems, Neil and others, Saradeep or others. Can you just walk me through your other solutions? There were other problems, right? There was a softmax problem, averaging min-max problem. Yeah, go ahead.
Sandeep, do you want me to share my screen?
Yeah, go ahead.
Okay.
Or anyone else, anybody.
Oh yeah, please.
तो देख रहा है बैठ के ये बंदा
Yeah, screen. Right. Anybody else wants to share? Please raise your hand. Okay. All right.
Sure.
No, Neil, go ahead. I think you wanted to share.
Oh, okay, sure. No, I was just waiting if anyone else wants to share.
Yeah, no worries, no worries. I think if anybody else wants to share, they can raise your hand.
Yeah.
Good. Yes, Divij, you want to share?
Okay.
Yes, I can share.
Okay. After this, let me just walk
Oops.
through.
Okay, I'll share it again. Okay.
All right. Okay. So you are saying convert this number to probability. What you did was you summed up all the values, then you went over the list and did the average of divided by the sum, correct? Then, okay, so this is correct. Convert to probabilities. So you converted that numbers to probabilities.
Yes.
Then comes the softmax. In the softmax, what you did was you did the 10 to the power of every value, And then once you have converted that, you basically call the same convert to probabilities and return the results. Good. That's very good. Yeah. Anybody else wants to share?
I will share my screen.
Go ahead, Divij. Very, very good. Very happy with the progress.
Hello.
Yeah.
Sorry, I got disconnected. Is my screen visible?
Now, yes. We can see.
The code was for this.
Okay. How to make it full screen? Okay, now it's better. Very good. Okay, so this is good. Very good. Convert to probability is perfect. This is perfect. Okay, go next. Okay, yes, this is also good. Okay.
I have kept the loop inside this only.
Yeah. Okay, you have also coded almost equals. Okay. All right. The binary search one, did you try the one? That one? The square root.
Yes, I tried, but I tried a different approach. I just like you said that we have to do it certain number of iterations. So I initially tried that. So it's like if I have to say like get 20 iterations, I ran this for 20 iterations, and accordingly.
Okay.
I did few cases for zero for negative numbers also, that it should not be a negative number. It's
Right.
like if I say
Right.
7, so it
Right.
so this was some extra iterations were there.
Okay.
That got the concept got clear in today's class that you said. I noted the same. Yeah.
Perfect. Code it up. Code all these other than square root and nth root. Do that. Code it up again. Good. Awesome. All right. Cool. With that, I think we will carry on with there are a couple of ideas that are still pending. Okay. I will go over those ideas. And yeah. Okay. Loops and iterations are done. Strings are done. Okay. I'll just go over strings quickly, though we have already talked about the strings, but I think still it makes sense to do it again. Okay. You can see my screen?
Yes.
All right. I'll just walk you through the strings, though we have already talked about, but I'll just give you a refresher. Okay. So we have talked about binary search, loops, iterations, and recursion, and quite a few interesting ideas. And as a side assignment, would you guys want to try the binary search using the recursion? Like first this range, then this range, then this range. Try that out. Okay. All right. So, all right. So now let's say we have the right. One of the common thing is like array of characters, or we call them string. The string is essentially can be within double quotes, within single quotes, within triple quotes. Okay. In case of triple quote, there is an added advantage that it can go to multi-line and so on. Right? So in case of string, if you do A plus B, there is no difference between string 1 and string 2. They both are strings. They have this one has double quote, this one is single quote. You can just concatenate them and so on. Okay. And then we can say, right, we basically, let's say there's a string here, string number 3, which is 1, 2, 3, which is essentially a number, but it's a string. Okay, it's a string, but it's basically digits. Okay, now what we have is, let's say, if we try to add 1 to this, it will basically not be this. Okay, now let me ask you this very interesting question to all. Okay, question number 4. Okay, given a string number represented as a string, convert it to integer. Okay, meaning if somebody says to num, that's your function. Okay, you have to define a function num, and it takes the string as argument and returns number. Okay, this is the signature I'm expecting, which also means that if somebody says to num 1, 2, 3, it should give 1, 2, 3 as a number. Okay, don't use you can achieve the same thing by using the internal library, this internal function called int. It converts it into the number. Okay. Yeah, Rahul, there's a noise from your side. Yeah. So, okay. So you have you basically can convert this using int function. Okay.
You're
How
saying
would
we can't use the
yeah?
Sandeep, you're saying we can't use the int function?
No, you are not allowed to use this. Let's say you in an interview, you are not allowed to use this. Instead, you have to code your own. How would you go about it?
To get the, I see if I have the string 1, 2, 3. So if I get a single 1, 2, and 3 separately, can I put the int conversion on that?
Int conversion on?
If I get the separately 1, 2, and 3 in an
Okay, yeah.
list.
So there's one, you can convert it like this. You can say odd.
Okay.
Okay, of this minus odd of 0. Okay, so this gives you the ASCII value. Okay.
Okay.
Odd of 2 is this is a 2. Okay. Odd of 0. Okay, so using this, using for this a single digit, you can use this.
Okay.
Okay. All right. So pretty simple, right? So if somebody says this single number, right? So it's pretty simple. So what you can do, anyone? Let's say, okay, if it's a single digit number, what do you do?
Compute the difference between
So
Okay, let's see. If this is a single digit number, length of this is 1, then you return
Order
of S minus odd of 0. Okay. Else what you can do?
by the multiplication we can do, like the based on the indexing, like the 123 first one is the multiply by 100, then plus 2 is the multiply by 10, then plus 3, then come to the 1, 2, 3.
Correct. Okay. If length of this is equal to 0, okay, then return 0. Okay. Else, if now what you can do is, let's say there are 2-digit number. What do you do with the 2-digit number? Let's say 1, 2. So you can do, okay, 2 num of 1 times 10 plus 2 num of, okay, 2, right? Makes sense, right?
Yes.
Now the challenge is if there is like 3, okay, what will you do? Okay. So instead, what we'll do is we will basically say whatever is the value of one, convert it into, we'll convert it into 1, 2 times 10 plus 3. Okay. That's okay. That makes sense, right?
Yeah. Yes.
So we can make it like a recursive call. Okay. So what we can do is we can say 2 underscore num of the entire number, whatever it is, except for the last one. Okay. And then multiply it with 10 and add it with
Last of.
last number. Okay. -1 in an array means last number. For example, let's say we have this 1, 2, 3, 4. Okay. So A of everything from the beginning till -1 means go till the last one. And A from -1 onwards means only 4. All right. So what we are doing is I'm just saying that give me the last letter and that's it. Okay. So let's take a look. Does it convert it into 1, 2, 3? It says this is wrong. Where did I make
You're
mistake?
calling the wrong method.
Oh, yeah, I'm calling the wrong method. Okay. All right. Let's see. It says, okay, expected string of length 1, but int was found. Okay, let's see what's happening here. To num, oh, here, this is the mistake. Okay, unsupported operands for none type. Okay, because I'm not returning it here. Yes. So does it make sense to you? Yes.
Yes.
Okay. What's the order of complexity of this one?
It's
Yes.
log n.
Are you sure?
Like n log n.
As we considering the length, no?
Let's say n is the length of this character, correct? So we are considering the length as the n.
Yeah.
O of n, because we are going through the whole string. If the string is of let's say 10,000.
Correct. Correct. So it is order of n. We are basically reducing one letter at a time and we are recursively calling. So we are basically removing only one letter at a time. We basically remove the last letter and call this method for previous letters, then that will do the same thing. So order of n. Okay.
Sandeep, why do you
Yes.
keep asking what is the order of complexity for almost every problem? Is it something that are we trying to build a muscle that will automatically help us
Yes.
next or?
Yes. You got it right. I want you to build this muscle. And I want this parrot on your shoulder to be sitting all the time, monkey on your shoulder, sitting on the time on your shoulder, asking you that, hey, what's the order of complexity? Because though it's not the programming language that matters much, it's the order of complexity. Many engineers or many non-engineers come to me and say, you know what? I'm using Python and my code is slow, and that's why I'm moving to Java, and that's the problem. And I tell them that you don't need a new programming language, you need better engineers. Okay. You just essentially, if programming language was a problem, then people wouldn't have built or the computer was like programming language is just something that can do everything. With Python, people have built so many complex systems. It's not a problem. The main problem is that when the engineers do not keep track of their order of complexity, it doesn't work. It doesn't work. Okay. I remember this entire discussion. One of my friends was doing the resume scanning and we had to search these. So the problem statement was very simple. The problem statement was given a list of 100,000 phrases and 10 million resumes. Okay. Find the best matching resumes for these phrases. Okay, so this was a problem statement. Okay. So you are given a list of, say, 100,000 resumes, 10 million resumes, and essentially you had to find those resumes which were matching these 100,000 phrases. Okay. And so this was a hard problem to solve. Okay. But the simple answer was binary search. And simple answer, the main problem that the engineers, and when I looked at the engineers' approach, they were lost. They were lost in Spark, Python, Scala, this, that. They were not tracking their order of complexity. I asked him in that, like the senior engineer, that you're doing this, what do you think is the order of complexity? So what he was doing is he picked one phrase, went through all the resumes, and that's what he was trying to do. Okay. While the answer is very simple, take all the resumes, take all the keywords from the resumes, sort all the keywords, and do the binary search on each of these keywords from the phrases, and then do the work. If you think about how does Google search, right? So quickly. The thing is, they have downloaded all the internet, created the list, sorted list of all the keywords from the internet. And when you are putting in the keyword, they're just looking at the sorted list of the keyword so that they are able to give you answer very quickly. They're not going through all the websites, okay? All the websites one at a time. No. Okay. Because if you go through the website one at a time, no matter which fast computer you use, you are going to take a lot of time. Okay. So that's why order of complexity is a muscle that you must have. Okay. Now, the aim of every engineer is to bring down the order of complexity to log. If you can achieve log, you have reached. Okay. The best order of complexity is order of 1. Then, all right. And then order of log n. Okay. Then order of n. Then order of n square. Okay.
In login.
There's also
Afterwards,
in log n.
In login.
yeah, before you, thank you so much for bringing that up. Yes, order of n log n. Okay. Now, the moment anything crosses n log n, this becomes unbearable. Okay, unbearable. And even when things are like order of n to the power n, that's kind of impossible to solve. Okay, these are the code where, right? So essentially the engineers psyche, the entire mindset is to figure out strategy to bring down the order from on square to somewhere here. Okay, and this is a common thing. Like, for example, let's say where you have to do, you have, again, let me just ask you this simple question. You have two lists of numbers. Okay, right? First list has, say, 100 numbers. Okay, this is the first list, everybody. Okay, first list is 100 numbers, and second list is millions of numbers. Okay, now find all numbers, okay, which are common in these two lists. Okay, so what approach would you recommend? I'll get back to the string things. I think we are going in a very, very good direction. Yeah.
I think break the first list into two and check if those first 50 is in the second list.
Okay. How would you do that?
Basically, break first list into two, as in like find the midpoint of those 100 numbers from the first list.
These numbers are not sorted.
Okay.
So I will read the first list and will insert into a hash table. And again, I will traverse the second list and look up into first hash table. If there is a hit, then I will.
Okay. Okay. We'll keep the hash table discussion separate for now. Yes, but your answer is good. Can you use binary search?
Yes.
Okay. So sorting, when you sort the data, it is n log n. We will talk about sorting very soon, and I would spend some time on sorting dictionaries. And let me finish the dictionaries, then I'll come back to sorting, and we will again look at this problem. Probably, I think it is better to just leave it for now. What do you say? So I think I'll just leave this question for everyone, and we'll come back to this, okay? And if one of you can just keep track of what questions are hanging, we will keep addressing those questions. This is something that I want to address. I think it's a little premature for the class. So yeah, but yeah, we are done with binary search. We are done with many things. And I think this is a little advanced for all of you. So I'll just move ahead for now. Okay. All right. Yes.
Hey, Sandeep. Hi, sorry. In your previous question,
yes,
the 100 numbers are a distinct number or they are?
Good question. Good question there. And yes, I would appreciate this if you guys can ask more questions. And in interview, when somebody throws this question on you, you should stop them and clarify. Okay, good. Very good. So these could be any number. They could be unique. They could be non-unique.
In both the list?
In the both list, yeah. For now, let's just to avoid the confusion, let's say that first list and second list, they contain the unique numbers. Don't worry about the duplicates for now.
And integers.
They're integers for now. Yeah. The integers non-duplicate.
Then I have one different, little separate question, because now I am in currently where I'm working. I have one project to improve performance, and
Yes.
tool is very old. Okay, so any documentation or any guideline, can I get any resource from where I can get?
No,
I mean,
so,
yeah. So you understand, right? Code is very old. I have to find out which area I have to go first and how to.
No, so I have done that multiple times at Amazon, at outside. I've done it multiple times that a very, very old legacy code is given and you got to improve its performance. Amazon was a typical same case. Okay. So the strategy is that, right, consider it as a large project. Okay.
Yes.
And first of all, what you got to understand is the various test cases. Okay, the way I always do it, that go through the code base and list down formally the various test cases. Okay, just to understand what exactly this code is doing and why is it doing. So do the documentation for yourself. And when you do that, when you understand the code, like which piece is doing what and what is the overall objective, and then you would be able to look at the problem and see what part can be optimized. Okay, what part can be optimized? Is there something that is being over and over done? Okay, so like for example, let's say take this case, in case you have two lists and somebody is basically taking each number, searching in the second list, the order of complexity is going to be order of n square, which is very high, right? That'll be 100 into a million, right? There'll be 100 million kind of times it is going to go, right? The other thing somebody could do is, okay, sort the second list, that will be of the order of n log n, okay? If n is a million, m is 100, let's call it m is the length of this one, and n is the length of this one. So sort the second list, it takes n log n times, and then for each of the first one, we are going to go over the second, do the binary search. Okay. So the total time it is going to take is n log n plus m log of n, right? So the total, because for each of the 100 numbers, each of the m numbers, we are going to look up in the second list. So m times log of n, right? So this will be the complexity of this one, right? And if we sorted the small list first and so on, then it could be the roles will be reversed and the overall complexity will be very, very high. Okay. So essentially the approach that I'm suggesting here, sort second list, right? For every element in second list, look for the values for every element in first list, do binary search in second list. Okay, this one takes n log n time, this one takes n log n time, and this one takes m times log of n. Okay, now there are better approaches. I'll talk about that very soon, but for now, this is good enough. And yes, so coming back to your point, is that in case of legacy code, once you go through the code base, you've listed down various use cases, you'll figure out a pattern that, okay, this is the piece of code which I can optimize, This is where I can use a data structure. And strategy always is to go for a simplified approach than a complex approach. Okay, go for simplified approach. Okay, and the more you simplify, the better will be your quality. And yes, and always revamping a legacy code gives you enormous amount of learning, and it gives you enormous amount of understanding of the subject. I have done it like multiple times, and every time I feel that it was a great value for me. And yeah, I think you should consider it like a opportunity than a pain. Okay.
Yeah, sure. Thank you.
All right.
Sandeep, I maybe sound like a stupid question.
No.
When you write, like maybe writing the code on Jupyter, so like hash is using for the for statement, wanted to comment something, like a
Yeah.
header. But
Yeah.
without, what is the shortcut for this? Like you, it's becoming
Oh,
bold
okay,
and
okay, okay. Okay, okay. I'll tell you. So see,
sure.
what I'm doing is there are two things. One is here, here. Okay. So, okay, for those who are new to Jupyter, so Jupyter runs in like two modes called command mode, and other is like editing mode. Okay. So if you press escape, you go into command mode. You can see when I'm pressing arrow keys, I'm moving outside. And if I press enter, I go into the text mode. You can see inside the text editor. If I press escape, I'll come out. If I press enter, I go into the editing mode. Okay. Okay. You can try. So enter means editing, and this escape means command mode. Okay. In the command mode, if you press A, it will insert a cell above, and if you press B, it will insert the cell below. Okay. In the command mode, if you you want to change the type of a cell from code to let's say markdown. Okay, let's say you want to do a bit of formatting. Let's say uh, list one, list item one, item two, right? Let's say you are trying to do this. Okay, and you basically want to make it like a markdown. Markdown is a formatting language, or you can say markup language, similar to HTML, which is markup. This is markdown. Usually people these days prefer for documentation markdown because you don't require a separate viewer, because markdown is very easy to read. Okay, so you either go here and press this markdown. I'm just pressing M. Okay, in the command mode, this becomes the code type. Okay, you can take a look at the keyboard shortcuts. Okay, so you can take a look at the keyboard shortcuts, and you can, right? So, I mean, to delete a cell, you can just say DD, save and checkpoint. Okay. And yeah. Also, if I'm in the cell and I want to comment, I usually press Control slash and Command slash on Mac, Control slash on normal, and it just comments out and comments out. Okay. I hope that answers your question.
Yes, Sandeep. Thank you.
All right. Okay. We will carry on with our discussion on dictionaries and sorting and other things. I want to cover sorting in details. I want to talk more about the algorithms, probably trees and data structures. And it's needed very much for everyone. As we go ahead and talk about objects and classes, I'll talk about the trees and creating data structures. And this is just to ensure that all of us are, comfortable with coding, because believe me, in every interview, people would ask you to code. Okay. If as a machine learning engineer, I would expect, whether you are just fresh out of college or a experienced manager, all right, it is expected that you do the code. Those days are gone. I met this guy who was some very senior person, and he was an abstract mathematician, and so-called abstract mathematician. And he said, no, I don't write code. I just explain idea. And I said that Nobel laureate, the last year's Nobel laureate who got the physics Nobel, he got it because of coding. Okay. So, and keep this in mind. There is no, honestly speaking, no branch of science as of today is like one of my student who he's an economist at this thing, one of the largest entity, IEF, and the where Raghuram Rajan works. So, IMF.
IMF.
Yeah. So yeah. So his entire work revolves around. He's a senior economist with a PhD, and he codes and he does entire machine learning modeling. Okay. So yeah. So everybody, no matter where are you coming from, make sure that you code with me. Okay. This is important. This is extremely important. Okay. And yes, spend your entire time of the week solving all the problems. Okay. All right. Thank you, everyone. Have a good day. We'll continue from here tomorrow.
Thank you, Sandeep.
Thank you,
Bye-bye.
Thanks,
So,
Sandeep.
So we are having a class tomorrow, right? Sandeep?
yes.
We are having a class tomorrow.
Oh, why
Okay.
this question?
Last week, I guess there was no class.
Oh, okay. Yeah. Okay. We'll have
Sandeep, would you share the Jupyter notebook which you did today so that I can just go through the questions?
Oh yeah. I'll just before we hang up, I'll just commit it, and everybody just make yourself comfortable with GitHub, and like these days, lawyers, writers, and everybody just using Git. Okay. And where are we with respect to the? I'll have to go here, go to my terminal. Okay. And it was something like Python, right? What was that? Python IITR. Okay. So git status. This is the new file. Oh, these are not committed. I'll just commit it right now. Git add. Okay. Git add this and git add this. Okay. And git commit. Okay. New notebooks. And git push. Yes. Okay, so I have committed it on my GitHub repository. So feel free to clone it.
Yeah.
All right. Where are we? This one. Okay. So yeah, I'll be pushing all the notebooks here. All right. Perfect. Looking forward to see you all tomorrow at the same time. Okay. Perfect. Thank you, everyone. Have a good day.
Thank you.